Go.
Hello.
Hello, Mr. Eric, Mr. Ryan. How are you today?
Good.
Have a nice weekend, yeah? It's Friday, okay? So, remember what we have talked about yesterday?
We talked about dynamics programming.
Yes, well done. Dynamic programming. Okay, so basically dynamic programming is an optimization technique, yeah, to speed up your algorithm, right? It's kind of like you ask computer to remember the things it has calculated, so it doesn't recalculate those things, right? Again. So it will save us time. So today we're going to talk about an interesting problem using this dynamic programming and possibly the permutation and combination. Yeah, do you still remember combination? Yeah. How many apples? How many apples you can pick? I mean, how many ways of picking 3 apples out of 5? So what's this number? Is C53? Yeah, picking 3 numbers out of 5. Yeah.
Yeah.
Without orders. Yeah. So what does it equal? Remember? It equals 5 times 4 times 3 divided by 3 times 2 times 1. Okay? Yeah? Okay? So it's 10 ways. Okay, so C n m equals n factorial divided by m factorial divided by n minus m factorial. Okay? Okay? Yes?
Yeah.
And C53 is equal to C52. Okay? It's the same because there are 5 apples, and if you pick the 3 apples, you also have a solution for picking 2 apples. Am I right? Yeah. Okay. So now, how about if I give you a grade?
Agreed.
A grade like 3, and then 4 maybe. So Eric, you are here. Yeah, Eric.
Where am I?
Eric and Ryan is here, right? At the top left corner. Possibly let's not the corner, okay? Let's put it in here, okay? You can walk in the squares.
What?
So you're here, and then Ryan is
Why
here.
are we naked?
No, okay, everyone, you're here, yeah? You can. Okay, what's this direction? That's east, yeah?
Yeah.
That's south, yes? Yes? So look, you're at the top left corner. And then every time you can walk 1 step to the east or to the south, but you cannot go to the north and the west.
Why?
I say so. Okay? Okay.
You forgot the word because.
Yeah, because I say so. Okay? So,
Why? That doesn't get more detail.
not bad detail. Okay, so let's suppose you can only walk east and
Where do
south.
you need to go?
You want to go here. Come here.
That's easy.
That's the target. So how many ways can you do it?
Lots.
Lots, yeah. So I want you to compute the number of ways you can do it. Look, you can do this, yeah. Or you can do this, or you can do this, yeah. Lots of ways. This is too a bit complicated. How about this? Just 2 squares. You're here, and you want to go to here. How many ways?
2.
Yeah.
There's 3. This one's 3 or 4.
Okay.
3 or 4.
Wait. So look, why you say this is 2? This is easy, right? Yeah. Because
2
it's easy.
or 2.
Okay, and how about I put another one here. So how many ways? You want to go to the right bottom corner.
3.
1, 2, 3. Yes, 3.
It's just about.
So how can we? So is that way we can count it, huh? So suppose there are n. There are n squares.
It's just like you just divided by 2 or something.
No, not even close. Look, there are n squares vertically and m squares horizontally. So,
Just change blue pinch.
yeah. So look, how many ways I need
Got a
to?
new one.
How many steps from the top left corner to the bottom right corner?
No.
How many steps? How many steps? So in order to work 1, 2, 3, 4, 5. 5 steps, yeah?
Yeah.
1, 2, 3, 4. 1, 2, 3. So
7.
no, 1, 2, 3, 4, 5. 5 steps.
Also, they can be like this. They
So then
can
look.
be different steps, like this.
No. You cannot go up. So look.
Oh.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you still get it?
Oh yeah.
So the total steps is fixed. So it equals m plus m minus 1, right? Because the first step doesn't count. Yeah, you need to minus it, right? Yeah, got it? Yes.
3, 1.
So look at this one. How many steps?
How do you know where north?
How many steps?
and west? North,
Uh,
south, east,
3.
3 steps. 1, 2, 3. Yeah, 1, 2, 3.
Yeah.
And 1, 2, 3. Okay.
1, 2, 3.
3 steps. So look. So how many steps going to the south? How many steps do you need to go to the south here?
2.
If 2, which is m,
Minus 1.
yeah, m minus 1. So you're going to south, m minus 1, okay? Are you going to the north? You need how many one?
3.
Which is
That's east.
east, which is
M minus 1.
1, 2, 3. Okay, so 1, 2, 3, yeah. Okay, why is m plus m minus 1?
My toothbrush
Why?
has been
Look,
charging a long time.
1, 1, 2, 3. So m minus 1. Okay? Yeah? So look, there are m minus 1 to the south, m minus 1 to the east. So altogether is m plus m minus 2. Okay? So actually it's m minus n to 3 plus 4. 3 plus 4, 7 minus 2. Okay? Yeah? So it's 5, right? 1, 2, 3, 4, 5. It's right. It's minus 2. Okay? Huh?
Yeah.
So of all these steps, this is total steps, and I want to pick number, the number of south. Does it make sense?
Yeah.
So for example, this one, there are 1 step to the north, and then there are 2 steps to the south, to the east. So how many steps? 3 steps, yeah? Yes? From those 3 steps, I want to pick 1 step to the north. Then that's the number of ways. Am I right?
Yeah.
So how many ways of this is C, 2 plus 1, and 1. Am I right? Eric?
Yeah.
Does it make sense? Look, Eric. So this is the total of steps, and among that, I need to pick the steps n minus 1 steps to the south, or n minus 1 step to the east. So the number of ways is C n plus m minus 2 n minus 1, or because this is 2 equal, right? C m plus m minus 2 n minus 1. Okay, so these 2 are equal, right? Remember, because these 2 added together will be the least. Do you still remember Cn m equals Cn n minus n? Remember? Yeah? Do you remember this? Yeah? The one we just talked about. Picking 3 apples out of 5 is the same as picking 2 apples out of 5. Am I right? Yes?
I thought it's M minus N, not N minus M.
N minus m, yeah, n minus m. It's the same. N is bigger. This is the total number of apples. This is 5 apples. 5 apples, I want to pick 3. It's the same as 5 apples, I want to pick 5 minus 3, 2 apples here. Got it? Yeah? So look, the total number of apples is n plus n minus 2, right? I want to pick n minus n 1 apple to decide to go to the south. So this is the number of ways. Do you get it?
Yeah.
Yeah, do you get it? So how many ways of this?
5.
No. Look, n is 1, 2, 3. M is 7. So C5, 2. What's C5, 2? 5 times 4 divided by 2 is 10 ways. There are 10 ways. Let's verify it, okay? 10 ways. 1, 2, 3, 4, 5. Here. 1, 2, 3, 4, 5. Here. Yeah? 2, 3. Okay? 4, 5, 6, 7, 8, 9, 10. Got it? So that's 10, yeah? So as long as we know the n and m, we know the mathematical ways to calculate it, the number of ways. Got it? Does it make sense? Okay, so look, this is the mathematical way of doing this, okay? So how can we calculate it? Remember? Look, Eric. Define, let's write it here. Define f n m column, yeah? Look at previously with n, so the number of ways is what? We want to know the cm plus m minus 1, minus 2, and minus 1, yeah? We want to calculate this number, yeah? Yes? Yeah? Okay, so actually, look, this is mathematics, yeah, but again, let's see this. If I'm at this point, I'm here, yeah, where can I, where could it possible that I come from? Which place? Which two? This is the beginning. So if somehow I'm at this point, so where was I in the previous step? Where could I come from? It's previous.
Top left corner.
Yeah, this is the starting point, and you can only go to the south, to the east, and go to the south. So I'm here. Where could I possibly go? Only here?
Here.
Yeah. So here and here, right? The previous step could only be here and here, right?
Yeah.
Okay. So suppose there are only one way come here, yeah? And there's only one way come here. So how many ways can I come here? 2, yeah, because here and here. Got it?
Yeah.
So look, this is original, f0, okay? f0, 0 equals 1, okay? And then here, suppose this is fn, m, right? So what does it equal? fn, m equals what? Here, fn, m minus 1 plus, here, what's here? F, what?
N,
minus 1, come on, what's here?
M.
Do you see this? In order to calculate this, I need to calculate this and this, because if I know there are maybe 20 ways to come here,
Oh, you need
and then there are 30 ways of come here, so how many ways I can come here? If there are 20 ways, I can reach this point, and 30 ways I can reach this point. Now, how many ways I can come here? Based on this? Based on this, right?
25?
Why is it 25?
No,
I just said add it together. What do you think? What are you thinking? Yes, 50. Look, so the target is then I can calculate this point, yeah, because I can calculate previous two and then previous two. So remember what is this similar to Fibonacci number? Yeah, the Fibonacci number. Look, fn equals fn minus 1 plus fn minus 2, right? Yeah, divide. It depends on previous steps. And remember, how many dynamic programming can we use? How many ways of dynamic programming? I give you a hint. Top down and what? What's the other way? Top down and what?
Down top.
No, bottom up. Come on, you forgot. Remember?
Yeah.
You remember?
Yeah.
Remember yesterday we talked about top down, fn, calculate from fn, and then I want to calculate fn minus 1. And then again and again calculate f10, f0 and f1. And bottom up is calculated starting from F0 and F1, F2. Got it? The same thing here. Top down is that I want to calculate the way to get the number of ways of getting this the right bottom corner, yeah? Then I need to calculate these two, right? Yeah? In order to calculate that, I need to calculate these two, alright? This is called top down. And then the bottom up. So can you tell me what's bottom up?
It's just like opposite.
Opposite, yeah, well done. It's from this point, yeah? I want to calculate here, then I know the number of ways I can get here and get here. And from this point I can get here. Why? Because each number is the sum of previous of these and then these. Yeah? Does it remind you of the Pascal triangle? Yeah? Each number is the sum of each shooter. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Each number is the sum of its above and the left. Got it? Okay? And this can also be calculated from top down or bottom up. Okay? Top down is I want to calculate this. And I go actually it's the opposite. I go calculate this with 3 and then I need to calculate these 2. And if I want to calculate this, I need to calculate this. A bottom up is that I calculate from the first row and then keep going until I reach the number I want. Okay? So here again, alright, pay attention, come on, it's very important here. Look, define f and n, okay? So if n equals 0, okay, the first one, or the first column, yeah? N equals 0, return what? How many ways can you do it? If I'm here, how many ways I can come here? 1. How many ways I can come here? 1, yeah? Because the first row and first column is always 1, am I right? Yeah?
Yeah.
Because you can only go to the south and the east, and there's only one possibility, you go straight, yeah? So this is return what?
Return 1.
Well done. And otherwise, return what? F, N, I'm here. It's the sum of these 2 points, yeah? M minus 1, M plus F, N minus 1, right? Yes?
Yeah.
Top down. Remember, we need to use the notebook, yeah? Remember yesterday in the notebook? Yes?
Yeah.
So how do we use the notebook? Here. Notebook. If, okay, a tuple, yeah? N, M, yeah? Look, if this entry is already in notebook, return notebook and M, right? Otherwise, the value equals Fn minus 1 M plus Fn n minus 1. And put it on the notebook. You just copy this, yeah? Yeah? Equals value. Return what? Return what? Return what? Return what? What are we calculating here?
Value.
Return value, obviously. Remember yesterday is the same. Remember? This is the same, exactly the same, except this bit. Yeah? Remember yesterday is Fm minus 1 plus Fm minus 2, yeah? Alright? With only one parameter. Now I have 2 parameters. So this is called top-down. Top-down dynamic programming. Okay? Top-down. Got it?
Yeah.
Okay, so how about bottom-up? Oh, remember, yesterday we talked about if we don't want to implement a notebook, we can put something at the beginning. Do you still remember? Add LRU cache none, okay? Or max size equals none. So when you put this, it means that the compiler, the computer will say, okay, I want to cache this function as much as I can. So meaning that if I see this parameter n and m, if you give me f22 and I have already calculated f22, then I will immediately return it without calculating it, right? Without invoking the recursion again and again. Got it?
Yeah.
Okay. So this is the magic keyword, okay? To save you from implementing the notebook. Okay? So from the bottom up, define f and m column. So look, we need to put it in array, right? So look, dp equals, we create a two-dimensional array, yeah? 0 for we specify the for I in range n, and then actually it's here.
It's been 21 minutes.
Okay, for j in
Yay.
range n. Okay,
Wait.
n m. So this is n. This is m. Okay, so now we have this dp, which is two-dimensional array. Two-dimensional, and then I need to specify the for I for row in range. This is a bit complicated. Range n. Okay, so n lines, and then I can say dp. The line r. The first one is 1, right? The first column is 1, and the same as for c in range n and dp c
Then the column is
equals
yay.
equals dpc actually is 0c equals 1. Okay, so that first row is 1, right? I put a 1 here, and I put a 1 here, and then for other values in the metric, for r in range 1n, for c in range 1c 1n. Okay, and then I can do this. Look at it. dp rc equals what? dp rc equals what? dp r minus 1 c plus dp r c minus 1. Okay?
Yeah.
Yeah? So look, we are using the for, and this is complexity is O m. Yeah? Because I need to fill in this metric, two-dimensional metric array. Okay, and then the last value I want to return is return what? dp minus 1, the last row, and the minus 1, the last column. So which is the bottom right column. Okay?
Yeah.
The bottom right. This is called bottom up complexity. Okay, so the one more thing. Okay, so this is as usual, and one more thing. Okay, so this is a bit tricky, but I think you must be clever to think about it. Yeah, look. So look again. This is the map. Okay, suppose I already give you the answer of f.
What is that?
And m is the number if they are n square. Okay, so suppose if they are n squares this side and m square this side, and then you can use this function to tell me to say, okay, the number of ways for Eric or Ryan to go from the top left corner to the right bottom corner is f and n. Okay, suppose you
Isn't it supposed to be here?
yeah. Suppose you already know. Suppose you can give me this. Okay? Yes. Now.
Is it supposed to be there? Finished.
Yeah, finish line. That's square. That doesn't matter. So this is okay. Okay. Okay.
In this square?
In this square, the last square. Okay. So now. F and n. Okay. So look at n is what? 1, 2, 3, 4, 5. So and 1, 2, 3, 4, 5, 6. So it's F5, 6 is the number of ways for Eric and Ryan to come from the top left corner to the bottom right corner. Okay? Yes? Got it? Okay, how about I said, okay, so Eric and Ryan must visit Tesco somehow. The Tesco is here. Tesco.
Today we just went to Tesco.
Yeah, Tesco here. So now, the same rule. You must go to the south and the east, but you must go here first. And how many ways of that?
2.
Wow, how is it?
Then 3. 3.
How many ways from
Then
here
4.
and here? For here
5.
and here.
28?
How is it 28? How is it?
To here from to here.
Yeah.
Uh,
You don't need to
6.
give me the exact
6.
numbers, but I
6.
want to know how you
6.
think about it.
6.
How you calculate it.
6.
How do you know it's 6?
Only a guess.
You only guess. So how
1, 2, 3,
do you know and
100.
so in order for Eric and Ryan to go here, these can be divided into how many steps? How many ways of can you do it?
it takes you.
Think about it. Think. So I give you a hint. How many? So you need to come from the top left corner to which place first? How many ways? Let's go. Yes. How many ways of doing that?
It takes you 3 steps.
F and in order to come here to here, how many steps? F. No, you don't need to give me the answer. I just need to know how many. F3, 2, right? Yes? 3 columns, 3 rows and 2 columns. Alright? F3, 2. Okay? Yes?
Yeah.
So that's how many we can calculate that. Yeah? And how many ways, and then what's next? How many ways of calculating from Tesco to this place? And how many ways there? 1, 2, 3. And then I say 1, 2, 3, 4, 5. Yeah?
Yeah.
So the ways of Tesco is F3, 5. Okay, so now this problem can be divided into 2. In order for you to go to this target, you need to go to the Tesco first. And then from the Tesco, go to this.
Is that a home?
Yeah, home. Okay, that's home. Okay, so I have 2 numbers. The number of ways from this to this Tesco is F32. Okay? The number from Tesco to home is F35. So what should I do? How many ways from here to here? What should I do with these 2 numbers? Should we add it or times it? You pick one. Should we add it or times it? Ready? Everybody, any thoughts? There are A ways to come to Tesco, and there are B ways from Tesco to home. So A, B, should I add it or times it?
Add, times, both.
I think it's probably add.
Why is that?
Times.
It's times. If of course it's times. How is that?
Nearly been half an hour.
Okay, so why is it times? Okay, can you look? If there are 2 ways of coming there, and then 3 ways of coming there. So how many ways?
5.
Why is it 5? For each one, I can pick 3. 1, 2, 3. And for this one, I can pick 3. 1, 2, 3. You get it? So it's 2 times 3. It's not 2 as 3. Got it?
Yeah.
Yeah, it's the multiple. It's not. This is very important. Okay. Got it? Ryan, do you get it? There are 2 ways coming here, and there are 3 ways going home. How many ways do you go home?
5.
6.
6. It's not 5. Look, 1, 2, 3, and then here, 5. 4, 5, 6. Do you get it? Because here.
I once said it.
Sorry.
I once said it.
Okay. So how many ways can you do it? If there are 2 and then 4 here, how many ways?
Because there's 6 in the row here.
Yeah, Eric, Ryan, look.
There are 8 ways.
8 ways. Yeah, because 2 times 4, right? Got it?
Yeah.
Yeah. So the same thing as here. This is the ways to go here, Tesco, and this is the ways of going home from Tesco. So you need to times it together. So do you get it? Do you see this problem? Yeah?
Yeah.
Yeah? Do you get it? Yeah?
Yeah.
I'm going to ask you tomorrow morning, okay? Give you a little pass.
But,
Okay?
but.
And then this is not yet. This is called dynamic programming, okay?
Been half an hour.
Dynamic programming,
Yeah.
okay? Say bye bye to people.
Bye.